let's quantify this. And quantities come from geometry, right? So we start off by drawing this line, right? From a side view, your true glide ratio. It's important to be able to just kind of get a sense of how far your parachute naturally wants to go in a zero wind environment, so that you can then extrapolate and interpolate, which direction it's going to go in terms of improving your glide or reducing it. So for instance, if you're facing into the wind, you change your glide ratio, right? So you're not changing your true glide. What's happening is, let's say it's a wind speed that cuts your ground speed in half. So let's say your parachute goes 20, the wind you're facing is 10. And consequently, you've got, there we go. You've got this glide ratio. So let's put this in real terms. So let's say your glide ratio in terms of just into the wind, this is your final approach, the distance that you travel. So this component here is the ground speed of your parachute, right? So from a side view, you have this descending mode, but from a top view, it's just about how fast you're moving across the ground. But then there's the descent rate in combination with that. So what that means is, if your glide ratio is 2.5 to 1, right? So that's an average figure for most people, it's a pretty good number. Student canopy closer to 3 to 1. Swooping canopy closer to 2 to 1, but that's the whole range. That's about it. So if you know those figures, then for every 1 foot you go down, you glide about 250 feet for the average person, right? And if you know that you're really, I'm loaded at less than 1 pound per square foot, and I'm on a 9-cell canopy, not a 7-cell, basically what that amounts to is I probably have closer to a 3 to 1 glide. So every 100 feet, I go 300 feet. So if that's the case in this basic geometry, in this wind condition, right, where I've got my ground speed is cut in half, that means that instead of 2.5 to 1, it's like 1.25 or something for my relative glide ratio. You see what I mean by the relative glide? That's the net of the blue line and the red line equals the green. So that's your into the wind glide ratio. And that tells you that if you're going to turn to final approach at 100 feet, you're going to go like instead of, we talked about 250, now it's only 125 feet horizontally for every 100 feet that you descend. You want to turn to final approach at 300 feet, advisable, right? So you turn at 300 feet above the ground. That means that you're going to cover half as much instead of 750 feet. Did you guys how I get that one? Right? Instead of this green light on the bottom, 750 horizontal feet. Now it's only this figure, right? So you cut that 750 in half, right? And so then you can take that number and then you look at the Google Maps and you can figure out where you should be turning to final. And that's the most important number. That's the most important XY coordinate on the map. So, if I turn there, I face into the wind, or more accurately, if I've completed my turn, right? Because you lose altitude and you lose glide during the turn, you have to sort of recognize that. If I know that figure, right? So here let's talk about designing a pattern based on this, right? So we've got a 2.5 to 1 glide. And see if you guys want to do the math for me. 2.5 to 1 glide. How far do I go across the ground in a condition where my ground speed is cut in half? Can you guys figure that one?
1.25 to 1.
1.25. Yeah.
Well, we have 1.25, and then you go times 3 if I'm turning to final at 300 feet, right? So that's 375.
Right.
So then I'm going to go to stop share. Whoops. And close window. So I like to build my patterns from the ground up. I have to close some of these windows. Okay, good. So let's go to the Google Maps again. we'll just pick a drop zone. All right, so let's say I want to land, where do you want to land? You want to land right here? Pick a spot. Let's be specific. Always choose where you want to land.
I always try and land on that white X in the, I guess, middle of the field. I think,
It might not be in this picture.
oh,
Oh, there it is.
It is. I was gonna say, I think that's
Is
it.
that the X? It's not much of an X, but okay. All right, so that's where we want to land. Measure distance. Let's start off with this figure of, what do we say, 3?
375.
Oh, I was pretty close, wasn't I? All right, 375. All right, so that's one dimension. So this is correct. Now, if I wanted to do a right-hand traffic pattern, then I'd have to figure out what the length of this is. And then this, obviously, this is an approximation, but let's figure out how to get this leg first, and then we're going to do this one. And I know that sounds complicated, but this is the one that gets complicated. All right, so this one's pretty easy. So what's the glide ratio of your parachute now? Let's go back to that that drawing that we had going on. Share screen, whiteboard. Okay, so now what we're looking is going the other way. So if I was to, let's do gold, reverse this direction of the wind. All right, so now I'm going to run. I'm going to tailwind. This is your downwind leg. And under those circumstances, my glide ratio now hasn't quite doubled, but it's certainly going to increase my ground speed by about, was it 50% more? So to get a rough idea of how far that goes, you can certainly do the math if you want to, but I find the downwind leg has a lot of variables. If you apply a little bit of brake, suddenly it extends quite a lot. And so what I prefer to do, instead of just, kind of getting a rough idea here, I could go, well, okay, so the length of this in comparison to this, we said was on a no wind day, 750 feet. So now you're looking at 750 plus another half again. So 750 divided by 2. I don't think you can see my calculator. So I have to add 375 to my 750. So 1125. So now I'm going to stop sharing this and share my other screen here. All right. So let's see how long that is. Let's see, measure distance. So what did we say? Set
11.
11. So that's an awfully long downwind leg, isn't it? If I fly for 300 feet of descent with that much wind, that's how long that leg is. And if you never took the time, and I'm not expecting you guys are going to take the time to do this every jump, but if you don't look at a situation and go, wait a minute, so my ground speed is going to be cut in half because I know my parachute flies at 20, 25 or something like that, and I know the wind is like half of that. That means that my run is going to cover a lot of ground. So the higher I turn into this downwind leg, the longer this leg is going to be. So I have a few options to shorten this leg. And the simplest one, anybody?
Height.
So in other words, I don't enter my downwind leg on a windy day at 900 feet. I might enter it at 700 feet or 750 or something. And so then I don't go quite as far. That's the easiest thing. And then what do you do before that? I would recommend maybe being here and flying facing kind of into the wind and just gently flying across the wind line because I'm barely moving. I can also start over here, but then I'm moving really slow. And if I'm a little late, I may not get to that point because the ground speed's so slow facing into the wind. And then I got to do a 180-degree turn, which causes what I call shoot off aggression downwind. You've got so much more speed. So I prefer to be across the wind line directly upwind of the target. So the nice thing about that method, and I'm going to move this stuff around a little bit just so we can be more specific. Okay, so we figured out this is about like that. We don't know exactly how far offset that should be. We figured out that this point, in theory, if we wanted to try a full box, it would be like that. Now, I don't know if I've gotten into this with you guys yet, but this is the magic square. It allows you to face into the wind, directly upwind of the target. I mean, I understand that exactly where that point is will vary depending on how windy it is, right? But if I fly myself from, let's say, 1,200 feet to 900, starting on the center line of my imaginary runway, I fly from 12 to 900. I'm creating exactly the correct amount of offset, right? Offset meaning this variable. How far to the side am I passing my target? The windier it is, the shorter this leg will be if I fly a box pattern on the ground. With respect to the wind line, I'm literally trying to trace my GPS path should be a rectangle if there's wind. And if there's no wind, well, that's a lot easier. That's just, of course, I'm going to cover more ground on this, but no wind at all. Looks like that, more or less. I mean, it's supposed to be a square, but you get the idea, right? So in other words, I'm starting at 12 over my target on a no wind day. I fly out as far as I get, right? So it's measuring my glide ratio by flying from 12 to 9, because it's the same altitude loss as from 6 back to the center line,
Right.
at 300 feet. So it's kind of a magic thing. It's just that when you're here pointed this heading to make your parachute move across the wind line, like let's say there's a little bit of wind, right? So you got to move this point in, you got to move this one in, and then you got to move this one out because there's some wind. And wrong one there. So now I'm here at 1,200 feet with my parachute on this heading, more or less. You see what I'm doing? And that makes me move across the wind line perpendicular. Yeah, I'm looking over my shoulder back at the target, but mostly I'm looking at the ground so that I kind of know that I'm flying a perpendicular path, perpendicular to the wind line. And then at 900 feet, I let it go. I make little adjustments on this leg, inside or outside, right? Outside or inside, to dial that in. And then when I turn to this heading, more or less, it'll make me move across the wind line at the same distance as this. It's just the distance varies with the wind, because if I have stronger wind, I have to crab more. I got to face more into the wind, which reduces my ground speed. And as a result, that is going to shorten my base leg. Now, this is only one model, and one of the things that you'll get from a Flight 1 course is a lot of propaganda about flying this kind of a pattern, where there's this, you can come from it, kind of anywhere. They don't think about that part of it too, but I suppose in theory it would be something like that. This is called the drift pattern. And what's cool about a drift pattern is that the downwind leg offset is going to be about the same as it would be on a no wind day, because I'm pointing my parachute perpendicular to the wind line. I'm pointing my canopy's heading perpendicular, and that's making me drift away from the target. How much am I drifting? I don't really know. That's the tricky part. That's the part that makes me not want to use this when I'm landing off the drop zone, when I'm in an accuracy competition. I would never do that. But if you've got a lot of canopy traffic doing downwind and base and final, you want them to fly their parachute on this heading and then 90-degree turn to the base leg, and then another 90 to final, to spread out the parachutes, because this drift model has nothing to do with accuracy. This is about trying to get everybody separated so we don't have canopy collisions. And I understand the value. The tricky bit is that if let's say you start here and you're 900 feet and you're cruising, and then you start your turn here, by the time you turn 90 degrees, you've drifted out to here, which means that this point's going to be out here, which means you're going to come short of your target. So what does that mean? It means that if you want to hit your target, you need to start your turn early. You might even need to start your turn on a day that's kind of windy before you even get to the target, right? I mean, not to the target itself, but in line with the target. And then, your parachute is now pointed on the base leg, perpendicular to the wind line, and you're drifting away. And then you can make little modifications on your base leg, turning away or turning towards the target to kind of figure that out. So I know that, Beth, this is a very long technical answer, but basically what I'm trying to map out here is the different models of getting to the target, this being the drift pattern, right? Where you're not flying a box on the ground at all, but you are flying a box with your parachute's heading, its compass heading. And so if you do a Flight 1 course, this is what they're going to want you to do. If you want to hit the target, I would suggest doing this kind of a thing, but of course that means that you need to shorten this leg if there's any kind of wind. How do you know how much to shorten it? You fly this pre-base leg. Sorry, I got this a little unsquare. There we go. You fly the pre-base leg from D to C from 1200 down to 9, where your heading is whatever heading is necessary to make your canopy move perpendicular to the wind line itself, like ferrying your boat across the river. That's exactly what this is. And then you ferry it back the other way, and the angles are just inverted, right? The angle that you needed here, let's say this is the canopy heading that you needed to hold, that angle will be the opposite of this angle. They're identical. Yeah. So that's the general gist of it. But here's another thing to think about is that, all right, so I didn't do my homework, or maybe the wind's changed. And I'm up there going, all right, I got to figure out this pattern. The wind changed direction, it changed velocity. How far am I going to go into the wind? Well, turn into the wind, look straight down, look at your altimeter, note the altitude, wait until you've got 300 feet less, and then notice where you are. And then you sort of look back and go, all right, I went this far. Now, if you do that directly over the target, you could get hosed and not be able to really fly a pattern because you can't move into the wind enough. So that's the trouble. This all has to be, these experiments have to be moved up the wind line, right? So you're going to be able to run back to the target from there. You're in a power position. You face into the wind, you mark altitude, and you go, all right, how far am I going in 300 feet? Oh, geez, I barely moved at all. Or, wow, there's less wind than there was earlier. The other thing you can do, of course, is do a run experiment. And so you just, same thing. I like to do a facing into the wind first. You kind of do that one and you see how far you went. And then you, noticing your altitude, you do a smooth 180 turn without diving the canopy too much, just sort of a gentle turn. And then sort of notice where you are and how high you are. I like to round up my numbers or round them to something easy to remember. So I'll wait to mark my location until I've lost, enough altitude for it to be 2,000 feet on the money or something, or 2,300, whatever. And then I notice, how far I went. And I'm basically just looking at my altimeter at this point, once I've noticed my location and altitude, and I just let it go until I get 300 feet down and I know where I am. I could always bring it back into the wind at that point and stop my ground speed, hold my uphill position, and just notice, all right, okay, that was this distance. Just keep in mind that when you run that experiment on a windy day, by the time your experiment is done, you could be past the target and not be able to get back. So that's one you should do once in a while. I think it's a good idea, especially new canopies, new conditions, but you do it really far up the wind line. You can also do it as you're coming back from your spot. Just keep in mind the wind gradient. The higher you are, the windier it is usually, right? So that does screw with your numbers a little, but not so much that it's going to, put you off the drop zone. It's just important to recognize that usually that's the case, and it helps to check your winds before you go up. Usually there's a whiteboard somewhere in the drop zone where the pilot wrote down, oh, winds at 3,000 feet are this, winds at 6,000 feet are this. And so you can kind of figure out roughly what that curve looks like. Because, facing into the wind, this is your curve. This is your glide. at first you don't really move, and as you get lower, your glide gets a little bit better because there's less resistance, if you will.
So theoretically, you could, if there was no wind, you could fly a complete square pattern, correct? Or no?
Square. And it works every time. It really does. It really works. Yeah. What if this was the best jump of your life?
I can see laughter, or I can see tears. I see a choice, love or fear. What do you choose? I can see peace, or I can see war. I can see sunshine, or I can see a storm. What do you choose? No, I choose to love where freedom flies from my heart, where the light keeps shining. And I choose to feel the whole world crying for the strength that we can rise above. I choose love. I choose love. I can see sharing, or I can see greed. I can see caring, or poverty. So what do you choose? I can see gardens, or I can see bones. I can see life or death,